If we want to size radiators, or underfloor heating, we can use the easy calculation at room level. The first thing we then have to select is the country. We can choose different countries, and if we select United Kingdom, we have to fill in the nearest city. Based on this, the location altitude and the minimum outdoor temperature are filled in automatically. We can manually adjust the location altitude, and this will then automatically recalculate the minimum outdoor temperature. We also need to enter the average temperature of the adjacent spaces, and by default this is set to 16 degrees Celsius. We are going to make a calculation for a residential house, so we select residential. Houses and flats fall under residential. All other types of buildings such as offices, schools, etc. fall under non-residential. We are making a calculation for a new building, so we select New Building, 2023 onwards. We select a brick building, and for the ventilation system we select Mechanical Ventilation with Heat Recovery, MVHR. If you hover over the blue question mark, you will get some more explanation about the different options you can select. For now, we indicate that not all rooms have been entered, and we will get back to this later. We can choose from different insulation profiles. We can also show the details of the insulation profiles, and we use the same insulation profiles as used in SAP calculations. If we select a year of construction, the U values cannot be adjusted. If we want to adjust the U values ourselves, we choose Complete in Detail. We can then fill in the U values ourselves, or we can indicate that the U value is not known. We must then select the insulation material and thickness, and Heatbox will automatically calculate the U value. For existing buildings, it's best to start from an insulation profile. You can then select the option Complete in Detail, and the U values of the chosen year of construction are retained, but now they are adjustable. For example, we see that the U value of the windows is very poor, and if the windows were replaced a few years ago, we can select here that PVC double-glazed windows are present. In our example, we are talking about a new building, so we select After 2022 as the profile and we make the details invisible. In our calculation, we are going to use both underfloor heating and radiators, and we are going to enter 2 rooms. We choose a living space and a bedroom. We indicate that the surface areas are 40 square meters and 14 square meters. Wherever you have to enter surface areas or dimensions in Heatbox, always use indoor dimensions. For the average height we keep the default value of 2.7 meters, and this is also an inside dimension. All cells with a gray background are automatically filled in, and can always be changed manually. The room type is filled in automatically, and the room temperatures are also filled in. For the living space, we are going to adjust the default value of 20 degrees to 21 degrees. For the boundary of the floor in the rooms, we have several options, such as ground, basement, other space, etc. For the floor of the living room, we choose ground, and the ceiling is adjacent to another space. If the ceiling is adjacent to part of a flat roof, and part of another space, we choose the part that has the largest surface area. This calculation provides a quick estimate of the necessary heat load, and if you want to fill in the boundaries in more detail, you can do so in the Pro calculation. In the bedroom, the floor is adjacent to another space, and the ceiling to a loft floor that is insulated. In the next column, we fill in the length of the outer wall in meters. Behind the scenes, we multiply this by the height of the room, and in this way, we calculate the surface area of the external wall. We also need to enter the length of the neighboring walls. By the neighboring walls, we mean the walls adjacent to other buildings, so the party walls, and not the walls adjacent to other rooms in the same building. If we are making a calculation for a terraced house, we fill in the length of the walls adjacent to the other buildings. In this example, we are making a calculation for a detached building, so for the length of the neighboring walls we enter 0. The surface areas of the windows are automatically estimated for an average house, based on the size of the rooms and the type of room. If you want to make a quick calculation, you can leave these values as they are, but you can also adjust them manually. We then click on the Calculate button, and we see that we need 2054 watts for the living space, and 570 watts for the bedroom. This is the power we need to heat the rooms to the selected indoor temperature at the chosen minimum outdoor temperature. For the living space, we select that we want to work with underfloor heating, and we see that we need 1572 watts. This is less than the 2054 watts we first calculated, and this is because the 2054 watts is the sum of the transmission losses, the ventilation losses and the heating up loss. The heating up loss is an extra boost that needs to be taken into account to heat up the room quickly. With underfloor heating, the room is heated continuously, and therefore we do not need to take into account the heating up loss. Furthermore, the transmission loss through the floor itself is also subtracted from the 2054 watts, and this is how we get the 1572 watts that needs to be supplied by the underfloor heating. The next thing we fill in is the blind surface. This is the part of the floor where we cannot install underfloor heating. This could be a kitchen island, or a built-in cupboard. If we fill in 4 square meters of blind surface, this is automatically subtracted from the total floor area, and we get a net area of 36 square meters, that can be used to install underfloor heating. For the floor finish, we have several options, and we choose a tile floor. For all stone-like finishes, you can choose a tile floor, and then we assume that the floor finish itself has no thermal resistance. For the layout distance, we choose 150 mm or 15 cm. The additional pipe length is the distance from the room to the underfloor heating collector. This distance is multiplied by 2, because we have to take into account the supply and return length for each loop, and by the number of loops. We need this length to correctly calculate the necessary pipe lengths for each room. We choose a supply temperature of 35 degrees, and a return temperature of 30 degrees, and if we click the calculate button, we see that the underfloor heating generates a power of 2038 watts, and the floor has a temperature of 26.4 degrees. We only need 1572 watts, so the 2038 watts is enough to heat up this room. The temperature of the floor should be below 29 degrees, and with the 26.4 degrees we stay below that temperature. For bathrooms, the floor temperature may be a bit higher, and we need to stay below 33 degrees. If we adjust the supply and return temperature to, for example, 37 degrees and 32 degrees, we see that the power increases, and the floor temperature also increases a little bit. For each room, we calculate the number of loops, the pipe length, the length of the edge insulation, and the flow rate. This information can be used to make a price offer for the underfloor heating at an early stage, without the need to draw everything out in detail. In the bedroom, we are going to install one radiator. In this column, we see the power we initially calculated, and we can change this manually. You may want the radiator to deliver more power than calculated, or part of the required power may already be delivered by the underfloor heating. We choose the maximum allowed height and length of the radiator, and we select the brand we want to use. In this calculation, we choose Stelrad radiators, and we choose a compact all-in, Type 22 radiator. We then get a list of radiators that at a supply temperature of 70 degrees, and a return temperature of 50 degrees, deliver 0 to 50% more power than we need. This means that we are sure that the radiators chosen from this list are going to be big enough to heat the room. After we select a radiator, we can click Calculate. We then see the radiator output at a supply temperature of 75 degrees, a return temperature of 65 degrees, and a room temperature of 20 degrees. This is the power output we typically find on the radiator's technical datasheet, but this is not the power the radiator will actually deliver. In this example, we use a supply temperature of 70 degrees, a return temperature of 50 degrees and a room temperature of 18 degrees, and in these conditions the radiator will put out 508 watts. This is more than the 570 watts we need, so the chosen radiator is large enough. If you can't find the radiator you're looking for in the database, you can also choose to enter it manually. You can enter the brand, type, description, and output power of the radiator. Before we continue, we select the radiator from the database again, and we see that we have a surplus for both rooms. The calculation we made is an easy calculation, and this means that certain assumptions have been made to be able to complete the calculation faster. For example, at the beginning, we said that the ceiling of the living room is adjacent to another room. If we make a calculation according to the BSE EN 12831 standard, that's not allowed. We would have to say that one part of the ceiling is adjacent to a bedroom at 18 degrees, and another part to a bathroom at 24 degrees, etc. Doing this for all the rooms takes up a lot of time, and to simplify this, we state that the ceiling of the living room is adjacent to another room, and at the top, we have entered that the average temperature of the adjacent rooms is 16 degrees. This is quite strict, because the average temperature in buildings is closer to 18 degrees. As a result, the heat loads we calculate are a little bit over-dimensioned, and compared to a detailed calculation, according to the BSE EN 12831 standard, we will end up with heat loads that are on average 5 to 10% higher. For the dimensioning of underfloor heating and radiators, however, this is not a problem, and this way we can be sure that the rooms will heat up adequately in all cases. At the top we also have the question, have all spaces been entered? If we answer yes, we see the calculated heat load at building level. This is the sum of the transmission losses, the ventilation losses and the heating up loss. This figure is quite low, and that's because we only entered 2 spaces. So, to calculate the heat load at building level correctly, you need to fill in all the rooms that are within the insulation layer of the building. Also, the heat load at building level is calculated differently from the heat loads at room level. At room level, for example, the transmission losses to adjacent rooms within the building must be taken into account, and this is not required in the calculation of the heat load at building level. This means that the sum of the calculated heat loads at room level will always be higher than the calculated heat load at building level. When we are done with the calculation, we can download a PDF report, and it will look like this. We see all the entered data, the chosen insulation materials, the calculated heat loads at building and room level, and on the last page, we see the data of the underfloor heating and the radiators that we have chosen. We can also download an Excel version of the report. This contains all the figures that were used in the calculation, but the Excel file contains no formulas. In the first tab we see the inputs and results of the calculation, in the second tab we find more information about the underfloor heating, and in the third tab we see a list of all selected radiators. If you have chosen many radiators, you can copy them from this list and paste them somewhere else. This can be useful if you are making a price offer for a heating system. This is the end of this instructional video. If you still have questions after this, don't hesitate to ask. We are happy to help you.